Let's take a look at finding the angle when the trigonometric function is given. Now if we have sine theta equals a, for instance if we have theta happens to be 45 degrees and we do the sine, that's 0.707106 and so forth. But if we want to go back the other way, given this number, and we want to find the actual angle, then we say second inverse sine and we get back our 45 again. Now the one thing to remember is 1 over sine of theta is sine of theta all to the -1, which is the reciprocal, and this is definitely not equal to the inverse sine of theta. One other thing that it tells you here, that calculators will give you acute angles only when you work these out, and acute angles means 90 degrees or less. So let's take a look at this one here. If sine theta is 0.7337 and we want to find out what angle that is, we can just do inverse sine and we get that it's 47.2 roughly to 3 significant digits. Now it says here if tan x equals this, find x in radians. Now the thing is that it works in degrees normally. If we want to switch to radians we have to click it, and notice it changes to degrees here, but it's telling us that we're really working with radians. So let's clear this. So we have 2.846 and we're going to do the inverse tan of that and we get it's 1.233, and that's the number of radians that we've got here. This one says if the secant is 1.573, find theta in degrees to 4 significant digits. Now 1 over the secant is what the cosine is, so that if we start with 1.573 and we want to work in degrees not radians, so let's switch this back and we do 1 over and then we do the inverse cosine of this, we're going to get that the angle is 50.5, and that is the right answer. Let's take a look at the specifics of right triangles. A right triangle is one that has a 90-degree angle. Now for any triangles, all the interior angles will add up to 180 degrees. So since this is 90 here, this plus this will add up to 90 degrees as it shows here. You should also be aware that based on the Pythagorean theorem, this sine here squared is equal to this side squared plus this side squared, or basically that c equals the square root of a squared plus b squared to find the length of the hypotenuse. So the sum of the other two angles, as we showed, was a plus b is 90. The sine is the opposite over the hypotenuse, the cosine is the adjacent over the hypotenuse, and the tan is the opposite over the adjacent. Now as you remember, the cosecant is 1 over this, and the secant is 1 over this, and the cotangent is 1 over this. Let's take a look at this right angle triangle here where C is 90 degrees. We're also given that this angle A is 18.6 degrees and that C, which is the length of our hypotenuse here, is 135 units. Now what we want to do is find out all the other information. So we're given this angle, we're given this length, but we want to find out what is our angle B and what are the sides A and B in terms of lengths here. So the first thing we can do very easily is figure out what is this angle B here, because we know that A plus B plus C, all the angles inside the triangle have to add up to 180 degrees. We already know that C is 90, therefore this angle B plus this angle A has to equal 90 degrees. So B, which is going to be 90, minus A, and A is 18.6. That gives it, we have 71.4 degrees up here. Now at this point we know that we can use trig functions when we say sine of A is really A over 135, cos of A is really B over 135. We can either use sine or cos. The book uses cos. We're going to do it a little differently. We're going to use sine. So the sine of 18.6 here is going to be A, which is this side, over C, which we know. So we know 2 of these, so we should be able to figure out the third. Now if sine A is equal to A over C, then A itself, which is the side we want to find, is going to be C times sine of A. So we have A is going to be equal to sine of 18.6, so let's put in 18.6. Let's do the sine of that. Then let's multiply this by 135. And what we find is we get 43.05, or roughly 43.1 is this side here. So we know 2 of the 3 sides. Now we also know that c squared, which is our hypotenuse, if we square that, it's equal to the sum of the squares of the opposite and the adjacent side here. We can rewrite this as b, which is the one side that we haven't figured out yet, is equal to c squared minus a squared. Value here for c, which is 135. And let's square that. And let's add that to memory. Let's clear. And let's subtract a squared. So a squared we found out is 43.1. So 43.1 squared. And let's subtract that from memory and do a memory recall. If we now do the square root of that, we do get indeed that our final side here, b, is 127.9. So given just two things, this angle and this side, we're able to figure out all the other information that we need for this triangle. Let's take a look at this triangle here. And we're given two things. We're given our angle here, b, is 55.2 degrees. And we're also given that our adjacent side here, a, is 207 units. And what we want to do is find out this angle a here. We want to find out also the sides b and c. Now the easiest thing to figure out is a, because a is going to be 90 minus 55.2. So let's do 90 minus 55.2. And so we find out that our a angle here. Now the next thing is we have this angle here and we know our adjacent side. And we know that the function cos is the adjacent over our hypotenuse here. And we know two of these three things, so we should be able to work out what the length of our hypotenuse is by saying the cosine of b, which is 55.2, is equal to a, which we know is 207, over our hypotenuse here, which is c. Now if we multiply through by c and divide by cos b, we get c is equal to 207 over the cos of 55.2. So let's put in 55.2 and take the cosine of that. And then we want to multiply that by 207. To do this, we need to do the inverse of that and then multiply this by 207. We get that the length of our hypotenuse here is 362.7 units. Now the last thing that we have to do, now that we know this side, we know this side, we know this angle and this angle, is to work out what our opposite side is here, b. Now if you remember that c squared equals a squared plus b squared, I think you can work out that b is equal to the square root of c squared minus a squared. So c squared, we can look at here, is 362.7 squared. And let's put that into memory. And let's clear this out. And then minus a squared. A we know is 207, so 207 squared, memory minus, memory recall, and all we have to do is take the square root of that, and we find that our other side here, our opposite side, b, is 297.8. So we were given two things here, and from that we were able to come up with our angle a here, our side c here, and our side b here. Now in this right angle triangle, we're only given two sides. A is 1.48 and b is 2.29. That's all we're given, and knowing that it is a right angle triangle. So we want to find is this angle a, this angle b, and the length of our hypotenuse here. If we want to look at angle b first, the tangent of b is equal to opposite over adjacent. So that's 2.225 over 1.48. So what we want to do is find the angle, and therefore b is the inverse tan of b over a. So let's take a look at b, which is 2.25. And let's divide that by a. And let's then do the inverse tan of that. We find that our angle here is 56.7 degrees. So since this is 56.7 degrees, then 90 minus that. So let's make a change sign here and add 90. And we find that our other angle here, a, is 33.3 degrees. All we need to do at this point is now find the length of our hypotenuse, which is the square root of this squared plus this squared. So we have 2.25 squared, memory plus, clear, and we have 1.48 squared, memory plus, memory recall, and do the square root of this, and we get that our other side here is 2.69. So based on just having two sides and knowing it's a right angle triangle, we can figure out all the other information about this triangle. When we're given a right angle triangle like this, also referred to as a right triangle, where C is our 90-degree angle here, if we want to find the sine of angle A, which is this angle here, the sine of A is the opposite, which is side A, over the hypotenuse, which is side C. So sine of A is A over C. However, if we want to do the cosine of B, which is this other angle here, the cosine of B is the adjacent side over the hypotenuse, which is again A over C, as we can see here. Therefore, the sine of A and the cosine of B are the same. These are called cofunctions. And so the sine of A is the cosine of B, the cosine of A is the sine of B, the tan of A is the cotangent of B, the cotangent of A is the tangent of B, the secant of A is the cosecant of B, and the cosecant of A is the secant of B. Now, if we take a look at this little problem here, it says if the cosine of the angle A, which is this guy here, is equal to 0.725, find the sine of the acute angle B. So let's put in 0.725, and let's do inverse cos. So that means that this angle up here is 43.5 degrees. Now let's find out what this angle is down here by doing a change sign and adding 90. So this angle here is 46.47 degrees here, and if we want to find the sine of that, we just hit sine, and again we get 0.725. And this is showing us that sine of B is equal to the cosine of A, and so the sine of B in this case is, as you saw, 0.725.